All right, hey Jackson and Ellie, this is 8-2. We're gonna get partway through this. We're just gonna do maybe the first couple examples and stop after the confidence interval method. Don't cross that off, don't cross that off. I'm crossing it off, but we're not gonna do it till tomorrow, so don't cross it off, okay? We'll do those, we'll get through the p-value method, critical value method, and then I'll give you some problems to do, okay? All right, so in section 8.1, we ran through the formulas for test statistics of proportions, means, and standard deviations, all three of them, right? This one, we're just going to focus on proportion, but we're going to do hypothesis testing all the way through, from step 1 to however many the steps are at the end, right? So, proportion, this is the test statistic. We call him Z, because he's a normal distribution. We're going to go through and we're gonna highlight and label what some of these variables represent. So what's the difference between p hat and p? Do you remember? Sample population. Which one's which? Samples p hat. Okay, so this is the number that we are testing, right? And p is the population, and these are all proportions. So like the other day when we did the M&Ms and they claimed 24% were blue, that would be p, what they are claiming. And now we're going to test that against the 27% that we actually got that were blue, right? So difference between what we're testing and then what they're claiming for it to be. P and Q. Notice that Q is not Q hat. This is the Q that goes with the P. How do you find the Q that goes with the P?
1 minus P.
Right, 1 minus P is Q, but it's not Q hat, it's Q, right? And then N is just N. N is the number in your sample. Okay, we know all those things. Have we labeled those all before? Probably, yeah. Okay, all right, so we're gonna start, just dive right into an example. Most consumers are uncomfortable with drone deliveries. Okay, I think we've done an example like this with drone deliveries before. What does that mean? Drone deliveries. Like they're picking the package up and they're dropping it off at your house. Can we foresee some problems that might occur with that? Yeah. One of my other classes said, like, let's just shoot the drones out of the sky. Like, well, I was thinking like weather might be an issue, but you know, that could be something also, right? Shooting the drones out of the sky. Okay, well, anyway, I would be in the list of people that are uncomfortable with a drone delivery. I don't think that's gonna work. I think let's not deplete our economy and make everything mechanical, and let's save some jobs here and have people deliver them. So anyway. But when they say most, circle that word. What does most mean? More than half. So the P that we're going to use is 0.5. It's going to be related to 0.5. Now we don't know equal to, greater than, whatever, right? But we're going to say most. All right. The chapter problem cited a Pitney Bowes survey in which 1,009 customers were asked. Okay, what is the 1,009?
Number.
N, that's a number. If they are comfortable with having drones deliver their purchases, and 54% of them responded with a no. Use these results to test the claim, circle the word claim, that most consumers are uncomfortable with drone deliveries. That's our claim, okay? So we've got a 54%, and then we know that we're going to use 50%. Which one is P hat and which one is P?
54% claim is...
The claim is the P. The claim is the P. So P is going to be 50%. Or 0.5, and our p hat, which is from the sample that we got. The sample of the 1,000 customers got results of 54%, so 0.54, okay? All right, we do need to check some things to make sure that these are okay before we can even do the process, and if any one of them fails, then this process of hypothesis testing doesn't work. For one thing, we need to make sure it's a random sample. If it's any biased sample, you were just giving me an example of that a little bit ago. If it's a biased example, they shouldn't have even done that hypothesis test or any of the data collection. But anyway, so unbiased, a randomly selected sample of 1,000 consumers. There is a fixed number of independent trials, and we have to have 2 categories. Okay, what are the 2 categories that we're talking about here? Of that 1,000, we're asking them this question. Comfortable or uncomfortable. It's like a binomial, either yes, no thing, okay? So we check those 2 boxes. Great. And then the last thing, we've done this before, where we have to check to make sure that NP is greater than 5 and NQ is greater than 5. So if we take 54% of the 1,000 and we take 46% of the 1,000, no, wait a second, P. 50% of the 1,000 and 50% of the 1,000, we have to make sure that that's greater than 5. If it's not greater than 5, then we're looking at like extreme values to start with, and normal distributions don't work very well when we're doing that. Do you have anything to add to that, Dr. Schneider, about N and P? Okay. Most of the time that's gonna not be an issue, because otherwise you can't do the problem anyway. So, and they're not gonna give that to you. All right. We're going to look at each one of these, p-value method and critical value method. I'm going to put the H0 and the H1 or HA in the middle because that's going to be the same for both of them, okay? We are testing to see, let's see, use these results to test the claim that most consumers are uncomfortable with drone deliveries. We said most means P equals 0.5. We always start with P equals 0.5 for that, okay? Our alternative hypothesis, not equal to, but if we're saying most, we're saying more than, right? So we're going to say P is greater than 0.5. Okay, which one is our claim? The bottom one. Does the claim always go with the bottom one or not? No. Okay, so it just depends on which one we're talking about. Here we're saying our claim is greater than 0.5. We're going to put in there. All right, which one would you like to do first? P-value or critical value? Yesterday we ended on critical value. Should we do that one first? You weren't here yesterday. You did? Okay. Sure. Let's go critical value because we ended on that yesterday. Should we do that? Okay. All right. So they don't give me something. They don't give me something. So we're going to make it up. They don't give me. We have to calculate the Z. What do they not give you? Up here in the top. They have to give us something. They don't give us the level of significance, right? So we're going to use 0.05 significance level. They will always give it to you. They, for some reason, maybe I cut it out or it got deleted out of this problem. We're going to use a significance level of 0.05. That's a commonly used one. It's kind of like the middle of the road. 0.05 level of significance. Critical value method. Here we go. Draw your bell curve. Okay, critical value method, we're changing everything to like a Z-score. So keep that kind of in the back of your mind. Critical value method, our middle Z is like the average, and the Z for the middle is going to be a Z-score of 0, because it is 0 standard deviations away from the middle. There he is. And I'm going to calculate the P hat minus P here in the middle, because we're going to need that for both sides, the critical value and the P-value method. So put that here, the square root PQ over N. Okay. All right, let's plop some numbers in here and let's see what we've got for a Z. Okay, which one was P hat again? 0.54 minus 0.5 over, we didn't calculate what Q was. What's Q going to be? 0.5 also. Okay, is this going to be a positive Z-score or a negative Z-score? How do you know positive? Yeah, P hat is the number that we got. 54% is on the right side of the average, which is 0.5, or the middle number that we're comparing to, 0.5, okay? 54%. Let's get a number. What do we got?
I have 2.54.
2.54. 2.54. Does that seem like an extreme value? Maybe? I don't know. We'll see. 2.54. All right. Okay. Which tail are we going to go off of? The right, because we're greater than, right? Greater than. So I'm going to shade this guy over here. And our level of significance is 0.05. Okay? If we had two-tailed, we would split it. We only have one tail, so all like 5% or 0.05 goes in there, right? Okay, and then I told you yesterday to kind of to figure out the Z-score that we're looking at, we kind of pretend, and Dr. Schneider's going to yell at me because he's like, why are you doing this? So just hear me out.
I'll be patient.
Because I don't teach this the way that he probably did. But anyway, 5%, you kind of pretend that there's a 5% on the other side, which means like the confidence interval or the middle interval that you're looking at being in the safe range or the close enough range would be 90%. Does that make sense? Okay, so 90% is in the close enough range. Those are not considered to be extreme values. And then we look at the chart to figure out the Z-score that corresponds to 90%. What do you got? 1.645 and negative 1.645. So we don't look at this negative 1.645 because that's kind of our pretend tail, right? Positive 1.645 is the right side. That's what we're going to compare to. And some of you guys have figured out our conclusion already. Do you know what's going to happen? Okay. We compare our z, which we got as 2.54. Okay. This mark right here, this 1.645, is like the cutoff mark for what is considered to be farther away from average than it should be, right? Okay, so if it's anything on this side of 1.645, it's like close enough to then 50% to say that that's close enough, right? Would you think that 54% would be close enough to 50%? Maybe, kind of depends. In this case, they say no, right? This one, the 2.54 is in the extreme range. So they're saying 54% is not the same thing as 50%, right? It is over beyond, okay? So that means that we do what?
Reject.
We reject this one, right? We reject the null hypothesis, which is saying that according to this information, maybe not in other samples. If they run this test again, maybe their data would say differently. But according to this data that we have here, the percentage of people who prefer drone deliveries is in fact greater than 50%, right? So we are rejecting the null hypothesis. What does that say about our claim, though? Our claim is right. Our claim is correct. Does that make sense? Okay, now if our claim went with the top, then our claim would be wrong, right? But because our claim goes with the second one, our claim is correct. Happy with that? Good? Yeah. All right, are we ready to be confused now to go back to the other method, right? Yeah. Which method do you like better?
Probably this one.
This one? This is the one that I like better. I don't know why. Do you have anything to add to that before we go on?
I like this one better.
You like this one better? Yeah, yeah, me too. Me too. Now you just wait till p-value method because I teach it not the way that not the way that I learned it. But this is what makes most sense to teach it, and it's not wrong. It's not the wrong way, but you get the same way. You just wait. You just wait. Yeah. Okay. All right. So I teach this not the way that normal people teach it, but it's not like it's the same. Okay.
Well,
so here you go.
You're not normal people.
I know, right? So anyway, okay. P-value method. Ready? Here we go. Make your bell curve again. We know that we're going to get the same results, right? Yeah. Or we should at least. If we don't, we did it wrong. Okay, so p-value method. Still have our bell curve. But we're converting everything to a p-value, which is like a percent value, right? I always think percent value, okay? 0% is on the left. This is where I teach it weird. 100% is on the right. Okay, and we have to figure out where our cutoff mark is. Okay? So we know that this is right-tailed and that there's 5% over here, right? I don't even look at like the pretend side on the left. If there's 5% here, my cutoff mark percentage-wise is going to be 95%. So we're like kind of looking at this as like a number line. 0%, 95%, 100%, yeah? Okay? So we've already done all the work from the critical value side, right? We look at this z value and 2.54, z equals 2.54. If we convert that to a p-value or a percentage, you're going to look up on your chart and you're going to go to the positive side, right? 0.9945.
Yeah.
Do we 0.9945 or 99.45%. And where does he live in relationship to the 0-100%? Extreme, right? He should, right? Like we already knew that. Okay, so still the same results. We're going to reject the null hypothesis, just like we did before. Should end up with the same answer, reject the null hypothesis, but our claim is still true, right? Claim is correct. Okay, all right, before we move on, or maybe that's it. Before we move on, let's write a sentence about that. Like, what does that mean? I think I already said it, but we haven't written it down yet. Okay, what does this mean? What are we talking about to start with?
Uncomfortable or comfortable with drone delivery.
Okay, so start me out here. What do you want to say?
We are 99.
Nah, don't worry about that. We're testing it and we're saying, yeah. Well, no, you're fine. So we don't have to talk about, well, maybe we do. I don't know. We're gonna skip that. We're not gonna add the confidence part of it. Let's just say, like, according to our data, according to the data that we collected. And again, if they would run this test again, maybe they would have a different sample. Maybe they would have an outlier in their data that would shove them over to the other range. I don't know. But according to our data that we have at this point in time, according to our data, the proportion of people who are what? Uncomfortable. I'm going to spell these words wrong. C-A-B-L-E, comfortable. Did I spell that right? I don't know. Are uncomfortable with drone deliveries is what? Is greater than 50%, right? According to the data that we have here, the majority of people are in fact uncomfortable with drone deliveries. So we probably shouldn't switch to that. If we are a company that is contemplating whether we should switch, we just found data supports the fact that the majority of people do not prefer drone deliveries. So we're probably not going to make that switch yet until people, you know, maybe warm up to the idea, which I don't know if they're going to. I don't know. Okay, good? Happy with that? All right, so let's do this. We're gonna wait to do confidence interval method tomorrow. If you want to look at the top of the next page, this is kind of the separation of p-value, critical value. This is exactly what we just got done doing. So those of you with terrible handwriting that don't have your bell curves labeled very good, they have the critical value and all the good stuff just like what we just labeled. So that's very nice for those of you with crappy handwriting. To the top of the back page, you can see exactly where all of that is labeled. Flip over to your homework and let's have you work on for critical value method. Let's have you do 1 and 2. Let's just have you do 1 and 2 on the first page and then switch over to the p-value method and do 6 and 7. Okay? I see on number 6 the word most highlighted or bolded. Okay, you're going to use that 0.5 again. So keep that in mind. Sometimes you might not use 0.5. 1, 2, 6, 7. Yep. Okay, now number 1, let's get you started with your p hat and p. Should we do that real quick? Okay, just to get you started. A certain drug is used to treat asthma. In a clinical trial of the drug, 24 of the 288 treated subjects experienced headaches. Okay, now that gives us a couple different things. 24 of the 28 experienced headaches.
Figure that out to get p hat.
P hat
Divide it.
is going to be 24 out of the 288. Okay, which is, I don't know what percent. 0.083. So let's go 0.083. When you do your calculations, you'll leave it as a decimal. Don't convert it. But that really means 8.3%. So 8.3% are experiencing headaches. Keep that in mind. What else do we know from that? Just that information. Don't read on. What? N. What's N? 288. Okay? Always look for the sample data. That will be your p hat. What are we comparing that to? 88%, which I'm pretty sure is supposed to be 8.8%. I think there's supposed to be a decimal there. Because if we're comparing 8.3% to 88%, that's going to be really bad. So, will you add a decimal in there? Yeah. 8.8. Okay, so your P should be 8.8%. But if you move the decimal, it's 0.088. Use those numbers to compare. Okay, do you think 8.3% is close enough to 8.8% to say that they're okay? I don't know. It depends on how many people we surveyed and stuff. Okay, so use that, get a start, see what you can do. Do one side, make sure 1 and 2 you're doing critical value method, and then the other 2 you're doing p-value method. Try those, okay? If you have questions, let me know. Good? All right. Everybody say bye, Jackson and Ellie.
Bye, Jackson and Ellie.
They don't care very much about you. Sorry.